Hello, everyone. I'm gonna wait a few more minutes, probably, just to give people a chance to join. So wait maybe till 05. Brian, do you have a question?
No, I was just waving.
Okay. Okay, let's get going. So welcome everyone. This is the one of the OAUTH Work Group virtual interim meetings. So let's get going. As a reminder, the note will applies here. So make sure you're familiar with this because this governs everything that we do at the IETF. So make sure you're familiar with this. Our schedule is today we'll talk about PICA. We have one more meeting next week and we will be done with those interims. Yeah, next week we'll be talking status list, OAuth status attestation, and global token revocation. So that's our schedule. Any comments, questions? If not, I'm gonna share the slides and see if I can hand that reins to Richard. Let me see. Slides control.
All right, I think I have control of that. Let's see. Yep.
Okay, over to you.
All right, thanks, Rifat. So I'm here with Sharon to talk about Pika. We presented this at the last IETF meeting under the name signed JWK sets, but we needed a catchier name and a cuter mascot, so we came up with that one. So this is largely, we got an internet draft published after the IETF meeting, and the content isn't really any different than what we discussed there. So this is kind of going to be a reprise of what the technical content we talked about at the IETF meeting, but now with an actual internet draft out there for folks to read. Hopefully some folks have taken a look at it, and hopefully getting to an actual adoption call at the end. Sharon, you want to say anything by way of intro?
Yeah, I just want to add that we did actually, like, we had our own design initially that we came up with, and then we realized we could actually pull most of the design from the OAuth Federation draft. So you're going to see a lot of format in here that we just like copied wholesale from there because it was exactly what we needed. So we figured not to reinvent the wheel, just pulled it right out and used it in the draft.
Yeah, great point, Sharon, and thanks to Mike Jones for that comment at the IETF meeting. There was a bunch of useful content in the OpenID Federation draft that we're using here. All right, so let's dive into background here to kind of get folks on the same page as to what problem we're trying to solve. So I think most folks on the call here have probably done this like OAuth OpenID dance, where you get some signed statement from an OAuth or OpenID provider, something like, some JOT, some ID token, something like that. And you want to verify the signature on that. So you need to have get the keys that are trusted for this issuer. Right, so there's a standard OpenID discovery mechanism that you use to go get that key set over HTTP. There's a similar one in SD.VC. Which it conceptually hangs together. You trust this thing because you download it over HTTPS from a specified issuer URL, but it has some problems in operations. In particular, the key that you're looking for to verify this thing isn't always accessible in that way. It can be accessible due to prosaic reasons, just like the key server being down due to some transient outage. Or it could be that the key's been rotated and you're trying to verify something older that isn't reflected in the current key set that the issuer is publishing anymore. So that's the kind of underlying problem we've got here. I want to talk about two ways that manifests. The first one comes up when we think about things like Mimi or like end-to-end encrypted Zoom or WebEx, applications like that, where we might want to use things that are issued by an OAuth or OpenID provider. In particular, things like verifiable credentials. So in these settings, when we think about normal OAuth-y stuff, normal OpenID-like stuff, like the client, there's pretty unitary clients. You're like using Google login to log into your favorite web app of the day, and the server over that web app does a bunch of these logins and caches everything. But in these new applications that are doing these end-to-end protections, the relying parties who are relying on these issuers are much more distributed. So in a meeting like this, where we're trying to present credentials to each other that are issued by some issuer, every individual software piece of software that someone's using here is a client. And so, you're not going to get caching benefit there because you're not doing a bazillion of these credential verifications. You get it within a meeting, but maybe not much more than that. And so, especially if you've got fresh clients, you're going to get a bazillion requests going to this key endpoint on the OP when people join the meeting or join the messaging session or what have you. So, like, that's annoying for the issuer, right? Because now they have this giant bump up in the amount of traffic they've got to handle on that key endpoint. It's static objects. It's not terrible, but it's annoying. And it's unnecessary, as we'll get to. And from the application provider's point of view, of course, there's downtime risk here. So your authentication aspects of your end-to-end security are reliant on this fetch going to an external provider that you can't control. And if that external provider is down, then people get login errors or authentication errors, what have you. So the idea here is that it would be nice if we could have some caching and redistribution of this of these keys that the clients need to fetch, so that something like the app provider can own its destiny a little bit more. So the app provider could fetch the OP's keys and cache them and redistribute them, without the app provider also becoming trusted by virtue of that, right? So we want the client still to be able to verify that the keys came from the issuer, but have them mechanically cached and redistributed by the app provider. And so, maintaining that trust, that when even though you're being distributed by untrusted intermediaries, is kind of the goal of the extra mechanism we'll talk about here.
And by the way, it's like very, very similar to the way if you might do a TLS handshake, you're not going to go get the certificate from the certificate authority. You're going to get the certificate as part of the handshake, right? Because it's been cached by the server. So this is very, very similar idea that we want to bring to OpenID Connect.
The other use case here, and oh yeah, go ahead, Sharon.
No. Yeah, so this is another use case, and this is a historical verification of objects that have issued by OPs. I should give a little bit of background on this, and I know there are folks in here that are like intimately aware of this application and working on it. So I don't know what the etiquette is, but if people want to chime in here, kind of where this application came from. But if you have a situation where, like what we have with OpenPubKey, which we've built on top of OAuth, or if you have with verifiable credentials or with SD-JOTs, or any kind of situation where you're getting a credential from an OP, where that credential has a binding between some kind of public key and an identity signed by the OP. If you want to use that credential, so you can see the square in the middle, that's the credential. You have the key of the developer, which is bound to the developer's identity. The OP would issue that credential, for example, in an SD-JOT, or for example, in an OpenPubKey PK token. And they would then allow the developer to sign something, right? So what we see here is we have the OP signing the credential in orange. Then that credential contains a binding between the developer's identity and their key. And then that key is being used to sign some other object, which in this example is a container. So if your application is you want to sign containers like some sort of software artifact, and you want to sign it using credentials that are issued by an OP, the difficulty that you may have is that the container may need to be living and being signed for a period of time that's longer than the lifetime of the OP key. So that's the fundamental problem. You have this container and it's signed, and you want to be able to verify it sometime after the OP key is rotated, or if the OP is not available at that particular moment that you're trying to verify. So you can't do this like magically. You need some sort of way of attesting to time. And so the solution here uses a time stamping authority. So imagine you have an authority that can say object X existed at times T. So we use that authority to prove that the verifiable credential existed at time T. Right? We could use, if we had that time stamping authority that was stamping that the credential was actually used at time T, we might be able to use it to verify that the container was signed at time T. Except there's one really big problem. How do we know what key the OP was using at time T if it's already rotated it and we have no record of what the OP was using at that past time, right? So the problem is we want to be able to take a credential from the past and verify that it is actually a real credential at that time in the past. And if we have a time stamping authority that can say this is what was going on at the past and this credential existed at the past, we would like to be able to validate that OP's key was actually the correct key at that time. Okay, that's what the PICA is solving. So the PICA is going to allow us to say that this was the OP's key at a particular time. And so it's unlike today where an OP may rotate its key and there's really no record for the outside world of what it did or what it was using in the past. With this, we can have a record of what it was doing at a particular time. So it's sort of two properties. What Richard mentioned was the redistributability and the caching. So the ability to cache the key and just redistribute it in application. So you're not dependent on the latency of the OP or something in a sensitive application. And in this case, it's actually having the credential and being able to look at it at some different time in the future and know that that was what the credential was at that particular time. All right. Should we go on, Richard, or do we want to?
Let's see if anybody has any questions about those use cases.
Anyone have other use cases you'd like to contribute?
Yeah, other use cases too.
We have some interest in this. I'm Joel from Jump Cloud. Been working with Sharon and you know, around some interest at actions taken by our admins as they manage policies, manage users, and other things. And admins may leave organizations, signing keys may change. So we're looking at a way of having a lasting record that some action, some policy, some command that an admin has done and signed by their key, even though that admin is gone, that key may be gone, we still want that chain of trust leading back to that signature. So that's where we're interested in this.
Okay, thanks, Joel. Anybody else? Okay, back to you guys.
Yeah, so as Sharon was saying, and thanks for the great kind of transition there, Joel, because this is really about extending the chain of trust. So right now with the technologies we have, we've got a way to take this signed object. There's several ways you can take signed objects, sign them with a key that's issued in a credential, something like a PK token or a verifiable credential or SD.VC, any of those kind of credentials in the middle. Those can get issued by OpenID or OAuth providers in various ways. And the discovery stuff kind of makes that tie together in the normal way you expect signatures to work. What we're adding here is a signed object format to say that OP key that signed the credential actually belongs to this OpenID provider, this OAuth provider. I'll use OP to be generic across this too. Right. So if you think about the discovery mechanisms we have today, you have an issuer field, an ISS claim, and a JOT, for example, that says the issuer of this has this domain name, and is identified by this URL, in particular that domain name. And the way that the trust chaining works in today's scheme, where you use HTTP to do a live fetch of the keys when you're verifying, if you think about it, the chain of trust there kind of goes. You chain up to the issuer URL, and then the HTTPS chains you from the issuer URL through the web PKI to some web PKI root of trust. So all we're talking about here, thanks Apple, is instead of doing that web PKI chaining through HTTPS and sending that in a TLS connection, doing that with a signed object instead. So instead of having a bunch of bytes over a TCP connection, you have a bunch of bytes in an X5C header in a JOT that lets you verify that this object was signed by someone who holds a given domain name.
So it's kind of like taking this online key exchange process that you would do in HTTPS and just stuffing it inside the PICA. And we have that X5C field. If you see the PICA is the square in the middle, we've got the X5C there, which is basically some sort of formatted certificate that is what you would have gotten anyway if you would have used as HTTPS. Although with just a little bit of an asterisk, because sometimes when I've talked to people about this, I've confused them by saying this chains to the same key you would use in HTTPS. We're not saying you have to use the actual key that's in your TLS box that's speaking TLS for you at that time, but we are saying that you would kind of chain to the same root, right, Richard? Like how would you explain that? What that key looked like? You can have a special key for your PICA, but we want to chain to the same place that you would have chained if you had been speaking HTTPS, right?
I think at the level of the specification here, we'll be agnostic as to the PKI, but I think in practice, the way you design it is to reuse the web PKI that people know and trust for these things already. So I mean, what a PICA looks like is basically, you take the JWK set you're used to distributing through that HTTP endpoint. You make that the payload of a JOT, and you put the certificate chain in the header of the JOT. So at that level, I think it's hopefully kind of unsurprising to folks. A couple of interesting bits here. You can see the cert chain up in the header. A couple of interesting bits here that we pulled from the open ideas are about managing the validity intervals of these things. So, right, obviously, JOTs have these IATs and X fields that define the validity interval of the JOT. Here, that's kind of nice because it bounds the validity of this statement that the OP is making about their keys. But it's also useful to do a similar dance for the keys themselves. So we have these IAT and X fields on the keys within the JWK set that define when the OP was signing with that key. That's useful, especially in those kind of historical use cases, because if you're trying to say, like, I'm trying to verify an object that claims to have been signed at time t, you can verify that the OP claims that they were signing with that key at time t as well. All right, so it's not just that you have a JWK set that expresses everything that's valid for an OP. You can also bound the lifetimes of those keys within the scope of this statement. I think that's the main.
I want to say something here. Yeah, I just want to say something here. So, like, another way to think about this is the OP keys each have their own interval, and that's like the interval for signing. And then there's another interval, which is the PICA validity interval, which you can kind of see at the top of the payload. And so that is how long this PICA statement is reasonable. And there's like one other really cool thing that actually Richard and I didn't design, but we just pulled straight out of the Federation draft. If you look at the second key, you can see it's like revoked at time, reason key compromise, reason code 1. So like we pulled that straight out of Federation. We didn't plan to put that in, but we saw it and we thought this is great because let's say you have a key that you had a PICA for and that key was okay. And then like a year later, you decided that you discovered that key had been compromised. You can reissue the PICA and say that key was compromised. And now you've basically revoked some sort of historical information. So we have that kind of for free. We got that out of the Federation draft. So that's there as well.
Brian, do you want to talk about the JOT type thing? I can't hear you, Brian, if you're speaking.
Oh, actually, by the way, do we have someone taking notes on this? Because it would be good to collect anything to make sure we get it reflected.
No, we got to do that. Like, I think Hannes didn't join today, so but yeah, typically Hannes was, and I completely forgot about this. Yeah. We have the recording anyway. Brian, go ahead.
You couldn't hear me because I raised my hand instead of unmuting, thus further showing my incompetence. Sorry, that's a total sidebar, but for the type, either use something meaningful based on the JWT BCP that I don't know offhand, but you can find it, or ping me and I'll send you a link, or just omit it entirely, but is a little pet peeve of mine. Type JOT is like just a waste of space and everyone's time. So it's a unnecessary pet peeve, but here we are. That's all I'll take on that.
Thanks, Brian. Christina.
Hi, yeah. You mentioned Federation draft. I was wondering if you look at a trust mark mechanism. So I feel like being able to add trust mark here might be an interesting way that can add additional attestations or something to the key chain. I mean, to be fair, trust marks are pretty underspecified in Federation, but just I guess I'm just pinging. Is there an appetite to explore that direction? And I can elaborate later. I'm not in a place to elaborate on it right now, but.
Yeah, so thanks for that. I admit I am unfamiliar with the trust mark stuff. I think without, with that caveat, I think I would probably say, like, let's solve the immediate kind of cryptographic trust problem first, and then we can go about adding more metadata after. Once we've got a signed object, we can add more metadata.
Well, that's the thing. Like in some use cases, the cryptographic trust, I don't know, at least in some of the EU use cases, that cryptographic trust kind of requires those trust marks in some use cases. But yeah, no, sorry, I'm boarding a flight. I won't be able to speak much after this. But in general, supportive of this draft. But yeah, I think that's one of the area from the EU use cases I know. I would be curious to kind of explore, update, follow up.
Great, thanks. Yes, this is the last slide we have. So I think the proposal here is we've got a draft out there for a couple of months at this point. I would propose that we take this on as a working group item. I know that's the chair's prerogative to actually make that call, but love to hear feedback on that idea.
Yeah, I think I'd like to wait until Vancouver. So when we have the full kind of work group kind of present there and discuss it there. So if we can plan on presenting this again in Vancouver, and then I think we'll be in a better position to make a call for adoption at that time. Make sense, Richard?
Yeah, I guess I'm not sure what we're going to gain between now and then. Maybe
More,
we could go ahead and like.
I want more people to hear this presentation, visibility, provide feedback, because the number of people attended here is limited compared to the full work group meeting in person, right?
Yeah, so if I may chair a bit from the floor, like a tactic I'd used as a chair sometimes in the past was to issue a working group second last call in a document to kind of solicit people to comment as if it were a last call. So maybe if you're worried about making sure that there's enough, folks who've seen it and do it, we could have some sort of, call for feedback, so that we could proceed a little more directly once we're sort of sure we have visibility, like you said. Karsten?
Yeah, I'm a working group chair, so I apologize if I'm thinking like I'm in the working groups I chair. But the point of a working group adoption call is to get this discussion going. And we have an interim here. We don't even need an interim to start a working group adoption call. And so I think pushing this into a working group adoption call is valid. There are a lot of people who are not saying anything but thinking, of course, this needs to be done. At least that's what I'm thinking. So why not just do a working group adoption call? And if problems come up there, you can always extend the working group adoption call or do another interim or whatever.
I don't think we need another interim. Vancouver is not far from now. Anyway, it's something I need to discuss with Hannes, and we'll make a decision later on call for adoption. Okay.
Anyway,
Brian, you want to say something?
I was half joking, but sort of trying to agree with maybe some kind of like warning or pre-call for adoption, message to say like turn up interest beforehand and then consider like looking at the call for adoption in Vancouver, but some, I don't know, nudge or something to try to pique people's interest before the meeting.
Yeah, that's reasonable. Thanks, Ryan. Joe, were you trying to say something?
Yeah, I mean, I think most of the feedback I've seen, there's been some discussion on the list, and I know we have use cases that kind of align with this draft, and so I think there's been some favorable discussion on the list. I think we'd like to encourage that, and adoption call is a way to do that, but you guys could do it in whatever way you see fit. But I think it would be good to have some more discussion here. But it's thanks to the authors for putting it together.
Okay. Awesome. Anybody else has any further comments?
Yeah, we've had a lot of meta discussion here about the process. If folks have substantive comments about like whether this seems like it's on the right path, or has the roughly the
Yeah,
right shape, that would be helpful as well.
I would love to hear from the Docker folks, because this is actually, so there's several folks here from Docker that we've been talking to. I guess they're not super IETFers like Richard and I am, so it would be lovely to have just some words from them and how they're thinking about this, just so the group can see. And then you can meet them as well. Maybe we'll see more of them in the community.
Yeah, that would be great. I see James in the queue there.
Hi.
Go ahead.
I am James. I said something in chat, but I'm working on supply chain stuff at Docker, and we looked at Open PubKey over the last year or so, and we've been following that project. And we're very keen on the idea that if you're building something on, say, GitHub Actions, you're able to sign stuff in the Open PubKey like way, sign images and add attestations, build attestations right there, rather than calling out to third-party signing things, which is kind of what everybody's doing. But of course, the log of public keys that Open PubKey needs is a bit of a stumbling block for us on that. So just to kind of add weight to the idea that this is like super interesting, we would be very keen to engage with OADC providers and push them in this direction if this was, I don't know how IETF works and how you get people to actually adopt these things, but people like GitHub and Google who are doing builds would be very interested in working with them to adopt Pika.
Thanks, James. So like officially, typically what we do is call for adoption on the mailing list. So the official call for adoption is always on the mailing list.
Got it.
So we would like you to engage and reply on the mailing list, because that's the right way to do it, right? So obviously these meetings are important, but when we make a call for adoption, it will be on the mailing list. So please monitor that and reply on the list. Okay.
Yeah, will do. I'm on there. Thanks.
Awesome. Johnny.
Hello. Yeah, I don't have much more to add to what James said. I also work at Docker, by the way, with James. Other than for what we're doing, like it would be awesome if this, was a thing that existed that we could use. It really feels like the missing piece of the puzzle for the Open PubKey container signing story. So yeah, I'll also be looking at that list and hammering the reply button.
Awesome.
Thanks.
Good. Anybody else? Okay. Richard and Sharon, thank you very much. I'll discuss this with Hannes, and we'll see what like. I just want to brainstorm it with Hannes, and we'll make a decision. It's gonna. We might delay it until Vancouver. We might push it a little bit earlier, but we'll let you know. Okay. Okay.
All right. Thanks for the time.
Thank you all very much. Thank you. Appreciate it.
Thank you.
Thanks,
Bye-bye.
everyone. Thank you.
Bye.
Thanks, folks.
Thanks. Hi guys. Can you guys hear me?